Good morning, students. So today we will learn about the free fall of an object. What is free fall? Free fall is nothing but the small g, which you all recognize as acceleration due to gravity. So how this free fall exists, what is the value of free fall, will be derived and discussed in this lecture. Right? So when free fall exists actually, when any object falls from certain height freely due to gravitational force, then such object possesses, इसके पास क्या है, g, small g, right? So as you all know that according to Newton's second law of motion, we can write F is equal to m into a, where F is the force, m is the mass, a is the acceleration. And here, as we consider, there is some object which is falling down from a certain height, so mass into g, right? And in our previous lecture, we have learned about universal law of gravitation. According to universal law of gravitation, force F can be written as capital G, capital M, small m divided by r square. What is capital G? Capital G is gravitational constant. The value of gravitational constant is 6.67 into 10 raised to minus 11 Newton meter square per kg square. We have also derived the unit for gravitational constant, as you remember, right? So what we can see from first equation and second equation of force, we can see here the left hand side of both the equations are same. So I can equate both the equations. So equating 1 and 2, that is m into g is equal to g into capital N m upon r square, right? So I will cancel out same quantities, then what will be remaining? Small g is nothing but g into capital M upon r square. So what we have achieved for small g, or acceleration due to gravity, that acceleration due to gravity is directly proportional to the mass of the object, and it is also directly proportional to the gravitational force constant, but it is inversely proportional to the square of the distance between the two objects. Then what we have learned from the universal law of gravitation, that two objects can attract each other, and this attraction is dependent on a force, that is F is equal to g m upon r square, right? So what was r? R is nothing but the distance between two objects, right? So this is the formula for acceleration due to gravity. Now what will be divided by the distance between the object to the earth. So value of capital G is 6.67 to 10 raised to minus 11, mass of earth is 6 into 10 raised to 24, distance is given. So I have just substituted over here, right? After substitution, what I have done, I have just separated the power part values and real numbers. Then in this step, I have cancelled the same values, and I have just divided 6 divided by 6.6. I will be getting 0.98 approximately, and by dividing these powers, I will get 10 raised to 13 minus 12. That is nothing but 10. So if I multiply 0.98 with 10, I will get answer as g is equal to 9.8 meter per second square. So this whole topic is divided in two parts. First is derivation. So we have started derivation with Newton's law, that is Newton's second law. F is equal to m into a, that is F equal to m into g. We have also used the Newton's second law, that, or we can say the gravitational law, that is F is equal to g capital M, small m upon r square. I have just equated two equations, as we can see that LHS part of both are same. So after equating both equations, I have cancelled out the same values, and at last I have got the value of small g as capital G m upon r square. At the later part, I have substituted all of the values which is constant for us, right? That is g is equal to 6.67 10 raised to minus 11 mass of earth, distance between the object, and at last we have read the value. Student, do write and practice this topic. You will surely understand this topic and will achieve full marks. Okay? Thank you.